of a material is found to be dependent on temperature. Different materials exhibit different dependence on temperatures. Over a limited range of temperatures, the resistivity of a metallic conductor varies linearly with temperature. Here, Pt is the resistivity at a temperature T. P0 is the same at a reference temperature T0. Alpha is the temperature coefficient of resistivity. From the equation or resistivity, the dimension of alpha is temperature inverse. For metals, alpha is positive. The relation of rho implies that the graph of rho and T would be straight line. At very low temperatures, the graph deviates considerably from straight line. The given formula can be used for a limited range of T around any reference temperature T0. This is the graph of resistivity of copper as a function of temperature. Some alloys, like nichrome, exhibit a very weak dependence of resistivity with temperature. Resistivity Pt of nichrome as a function of absolute temperature T. Manganese and constantan also have similar properties. Their resistance value would change very little with temperature. Therefore, they are widely used in wire-bound resistors. Unlike metals, the resistivity of semiconductors decreases with increasing temperatures. Now, we can understand the temperature dependence of resistivity qualitatively. From the given equation, we get resistivity of a material. Here we observe that resistivity depends inversely both on the number and of free electrons per unit volume and on average time tau between collisions. As we increase temperature, average speed of electrons increases, resulting in more frequent collisions. The average time of collisions, tau, thus decreases with temperature, resulting in increase in resistivity. In metals, the number free electron density is not dependent on temperature to any appreciable extent, and thus decrease in tau with temperature will cause resistivity to increase. But for insulators and semiconductors, an increase with temperature, and this increase is more than compensates any decrease in tau, so that for such materials, resistivity decreases with temperature.